So great to see you guys here. My name is VanStee, and I work out of Poughkeepsie, and I'm the North America Z blockchain technical leader for tech sales. So a little bit about my background, and I just have to I've been working at IBM for 18 years as well, just like Jeff. I think we probably started at around the same time, 2001. Yeah. Okay, yeah, well, summer.
I had a year of an internship.
Gotcha. Yeah, so I started in 2001 in IBM Poughkeepsie, kind of straight out of college, and I went to State University of New York as SUNY at New Paltz, which is sort of right across the river from Poughkeepsie. And IBM was one of the technology companies that recruited at SUNY New Paltz. And I still remember interviewing at IBM Poughkeepsie, and I had 3 interviews they lined up for me. And it was like Art Palmiotti who recruited me. I don't know if you remember Art. Yeah, he was great, wonderful, wonderful man. And the 3 interviews, the first one was with ZTPF, okay, which is this operating system that a lot of hotels and airlines use for reservations, right? And it's still being used today very heavily by these major companies. And I had no idea what ZTPF was. The second interview was the JES2 subsystem, a developer. And again, I was like, what is that? I have no idea what that is. And then the third job interview was to do Java system tests. I'm like, Java, something I learned in college. So that's the one that I took. And it was to do Java system tests on the mainframe. And during the first 2 years, I really learned about how crucial the mainframe is, and it's still being used by so many of our Fortune 500 companies, local governments, federal governments, healthcare industry, industrial, so all the different verticals that exist today, they all have some kind of a mainframe in the back end to host all of their very critical business transactions and business logic. So all things like credit card transactions typically go through their claims data for your medical insurance companies, for payers, typically go on there. Welfare systems, student information sometimes go in there, depending on which agency you're talking about. But yeah, so I learned more and more about this very crucial business environment, business platform for a lot of our enterprise clients. And then the other thing that kind of resonated with me from Jeff's talk was when he said, IBM is sort of like this place where people kind of get together and just develop things, kind of skunkworks projects, and then all of a sudden it becomes adopted by the whole enterprise. And Linux on the mainframe was one of those projects. Like, I think it started out by this one guy in Germany who's like, why don't I port Linux onto the mainframe and let's see what happens. And this is about 20 years ago, and it just took off, right? So many of our mainframe clients use Linux on the platform today, and the Linux distribution is able to take advantage of all the benefits of the mainframe platform. And another project that sort of started out as a skunkworks project is blockchain at IBM. And this was back in, I think, 2014, 2015. Again, a group of IBMers kind of saw this cryptocurrency space, right, that's kind of taking off, with Bitcoin, Ethereum being 2 of the most popular cryptocurrencies. And they thought, well, it has so much potential outside of just the cryptocurrency use case, right? Because essentially it's really a distributed ledger technology to track any type of asset. And cryptocurrency is just one of those assets when you think about it. So how can we adopt it for enterprise use, for businesses? Because businesses do businesses with other businesses, right? Whether it's their suppliers or their co-opetition, right, what have you. And they have shared assets. And oftentimes the businesses don't trust other businesses to give them access to their own database, right? So what do you do in that time? Well, you need to share common information with each other about a certain asset that you all have an interest in, yet you don't trust one another to access your own system. So that's where kind of enterprise or permission blockchain comes into play. Right? So this is straight out of Wikipedia, I'm not gonna lie. But really, what is blockchain, right? And from a technical standpoint, it's really just a growing list of records called blocks. If you take computer science, you know what a linked list is. Yes? Computer structures, yeah? It's sort of like that, but there's a lot of cryptography involved, right? And the blocks are sort of linked by cryptography. So each block has a hash of the previous block. So if an attacker was able to attack one block, the hash would change, and the attack would be detected. So by design, blockchain is resistant to modification of the blocks. So one of the tenets of blockchain is immutability. So sort of what you put on the block, a transaction, you cannot modify the history, right? You can't just go back and say, well, something changed. If you need to modify the attributes of an asset on the block, you have to add another transaction, basically add another block to say, well, I made a mistake or something modified with this asset, so now here's a new block. And really it's to solve the problem of, again, businesses doing business with each other, but they're doing it, they always have this like reconciliation process, right? Where you have to sort of reconcile my records with your records at the end of the day. And I think of this example when I first started working and actually started making money. I opened a bank account, and most of you are probably too young to even know about what this is, but how many of you know what balancing your checkbook is? Wow, quite a few of you. I hope you don't do that today. But back then, I did that. Right? 'Cause my parents, it was like back. Some banks had, kind of online banking. You kind of you can kind of see your history of transactions. Other banks didn't, right? And I just happened to, join like the local credit union, right? Because I guess IBM had to deal with it. So, so my parents said, you got to balance your checkbook, right? So I'm like, okay, I will definitely do that, very diligently. So what it is I kept a ledger of my bank account locally, right, with myself. I wrote it down, very manual. Meanwhile, the bank also has a copy of the ledger of my balance. And then, every once in a while, I would go in and make sure that like we match, right? So that's a very, very small example of two different entities keeping separate ledgers of the same thing, right? So, and banks do this today when they need to settle payments with other banks, for example. Health providers and payers do this today when they are looking at the health record of the same individual. They have different databases that keep track of those records, right? So it becomes very inefficient when there's a lot of parties in the same sort of business network that need to exchange information, that need to share data about a common interest, about a common entity. So this is where blockchain can come in and help with that. It's a shared, replicated, permissioned ledger. So shared means that every party in this network has a copy of the same ledger, right? Replicated means that the ledger copies at everybody's, location or cloud of choice, is the same, is kept the same. So replication means, whenever I update my ledger, it gets replicated over to your node and then gets replicated to other nodes. Permissioned, and this is where the difference is between permission blockchain and permissionless blockchain. So in the case of the technology that IBM invested in, is permission blockchain. So you typically know who you're dealing with in a business setting, right? Like I know that my bank is this bank, right? And the bank knows that I am a customer at this bank. And usually when banks need to settle payments with each other, they also know who they're settling payments with, right? So this is very different from a permissionless blockchain. So something like the cryptocurrency world, we have Bitcoin or Ethereum, you can basically kind of join that network anonymously, right? And that's why it's so resource intensive in order to actually add a block onto that blockchain, right? So I'll talk a little bit about that, but essentially it's really just a shared distributed ledger technology, and there's multiple out there. So the IBM open source project, that IBM contributes a lot to, it's called Hyperledger Fabric. It's a project under the Hyperledger umbrella, under the Linux Foundation. So IBM donated a lot of code to this open source framework, and it's one of the I guess mostly used distributed ledger technologies out there for permission blockchain. Again, so I talked about this different types of blockchain. So how many of you have heard of, like, I'm sure everybody's heard of Bitcoin and cryptocurrency, right? So what are the characteristics of cryptocurrencies and Bitcoin and things like Bitcoin? I mean, you can cheat. Yes?
It's not trackable, so you could implement it in underdeveloped countries if you want to send donations. And a lot of people don't have bank accounts, and you don't need a bank account to cash out your Bitcoin. You can just have a digital wallet. So it can help people, with no identification or no bank account.
Yep, that's very good. Go ahead. So anonymity, yeah, cash has that attribute of being anonymous, right? Like I give you $5, you have no idea where I got that money from, right? So yes, so basically, so Bitcoin is really the most prominent example for permissionless blockchain use case. It's really the first blockchain application, right? It came out of this white paper that this anonymous group of people wrote, Satoshi, back in, I think, 2009, and then it really became, it flourished around the year, 2011, 2012, and it really became part of the public eye around 2015 when it took off. It's very resource intensive, meaning because of the anonymous aspect of Bitcoin, you really have to kind of prove that you're not a bad actor, right? And in order to do that, you're really devoting a lot of resources in terms of compute and energy resources in order to prove that you're not a bad actor so that you can help commit transactions or group transactions into a block and commit that block onto the blockchain. So blockchain for business is very different. So again, it's the same underlying principle in terms of, that it's a distributed ledger, right? But it prioritizes assets over cryptocurrency. And again, cryptocurrency is really just another asset. But what we're saying is you can put anything on the blockchain, not just currency, not just digital currency. And it prioritizes identity over anonymity. So you have to prove that you are who you say you are when you are trying to transact on a permission blockchain, right? So instead of Bitcoin, where you can kind of join anonymously, with permission blockchain, you have to prove that, I'm Jin, right? By showing other participants on the network my certificate, my X509 certificate, right? So that's how it's done. It's all done through really PKI. And then it does selective endorsement over proof of work, because you do know who you're dealing with, right? Whenever you know who you're dealing with, or people are transacting with their identity attached, it on its own sort of decreases the chance of bad action, right? Because their identity is attached to every single transaction request, every single endorsement, every single commit. So you know who did a bad action, right? So it's just similar to like online forums or chat forums. If it's an anonymous forum, people are crazy, right? I mean, just trolls coming out everywhere. I mean, even if you're not, even people you have identity attached, and forums where, you kind of have to prove that you are who you say you are, people act like a lot more civil to each other, right? So it's sort of similar concept. You have to prove that, you are part of this network. People have to agree to have you join this network, to kind of vote on it. So you sort of act better, just in and of itself. It's just because you have to prove your identity. And then selective endorsement over proof of work. So the consensus algorithm used in Hyperledger Fabric is something called selective endorsement. So really, instead of proof of work, you have to it's very resource intensive, compute intensive. Because you know who you're dealing with, you don't really need to do that, right? So instead, selective endorsement says, you kind of have to set the endorsement policy when you first set up your network and say this person or that person or that person has to endorse this transaction before the transaction is deemed valid to be added to the blockchain, right? So that's the concept behind it. So any questions on permission blockchain at all? Yeah. So how you prove you are who you are is with X509, is with PKI, public key infrastructure. So we use basically X509 certificates, right? So you basically get a certificate from a certificate authority, someone like VeriSign, right? Like someone that can really back you and say yes, you are who you say you are. And you basically attach any transaction proposal, any endorsement transaction, any transaction commit. It's all your identity, your X509 certificate is attached to every single transaction. Yeah.
The certificate ability conduct a thorough check of who you are. They check your identity. You have to prove your identity to them, and they can distribute.
Right. Yeah, and because this is really a lot of businesses are doing this, so businesses themselves will get a certificate to represent the business on behalf of the people in their organization.
Could several nefarious businesses get together themselves and create their own chain?
Yes. Sure. Yeah.
So how do you reconcile differences? Like if you and I work together and my, checklist doesn't align with your checklist, what happens?
So typically today, when that is done in the manual process, it's a reconciliation process. So, or sometimes it could be called dispute resolution. There's a dispute, right? There's a mismatch. And that was actually one of the first use cases that IBM used blockchain for, is to settle disputes, or basically, just differences in our different ledgers between IBM and our suppliers. Okay, so people like Lenovo who supply our workstations. And that process could sometimes take 1 to 2 weeks to resolve without blockchain. Now, when they started putting this process on the blockchain is the single source of truth. So basically, it makes the dispute or reconciliation process a moot point, because you have a ledger of all the transactions that have happened. I have the same ledger of all the transactions that have happened that are cryptographically secured. So you just got to refer to the blockchain. We have the same results, right? So for the vendors or the suppliers that are on the blockchain, that's how we resolve disputes. It's just go reference the blockchain. For the vendors that are not on the blockchain, we still have to go through the manual process of. So that's a good question, right? So IBM started out offering blockchain as a managed solution in the cloud. But now we realize that the true nature of blockchain is distributed, right? That nobody owns all of the network, that everybody owns a little bit of it, right? And that's how you engender trust. So now the strategy is blockchain anywhere. So for you, for me, I may prefer to run my blockchain peer node on the mainframe because it's secure. But for you, you may want to run your blockchain peer node in Azure or Amazon. And you can do that, and we can still be connected in the same network. So does that answer your question about where to run the different peer nodes? Yeah, so it really is because it's decentralized, right? And so we have clients that are doing this today. Yes?
Can you compare
So are you talking about? So if you have blockchain, your ledgers are the same. Okay. So you don't have to worry about reconciliation. Without blockchain, yeah, some people it's typically a very manual process, and you have to go back, kind of through a history of records, and whether or not you trust those records is another story. So a lot of our clients are looking at blockchain just for reconciliation, because once you have blockchain, our databases look exactly the same. Yeah. Yes.
When you say that an identity is assigned to like the user to prevent bad behavior, when you say bad behavior, do you mean like messing with the blockchain or like preventing criminal activity? Like from my understanding, Bitcoin is used a lot by criminals because of anonymity. So
Yes.
you mean that bad behavior?
Yes.
Oh.
Yes, and also just people messing with the blockchain, right? So if there's that identity attached, and it's a requirement, right? So anybody that's going to join a permission blockchain has to assert their identity, and basically everybody else in the network has to kind of vote to agree to let you join the network, and then once you join, everything you do has your identity attached to it.
So if the identity gets hacked,
Yes,
so there's a process.
that's right. Oh.
Pinpoint where it happened and how to reverse those transactions, or add another block to fix those transactions if it's clear that that identity is hacked.
Well, so I'll talk about the security of a blockchain network, because the identity is super important, right? And the securing of your identity, or securing of in PKI, it's, you have your public certificate, represented in the certificate, right? In everything you do. And then, but you have a private key, right? That really is your, that's like the access to your identity, to the network. And I hear a lot of like these hacks of different cryptocurrencies. A lot of times is because the wallet has been compromised and people have accessed the wallet and have accessed the private keys of all these people, and are able to steal cryptocurrency because now they have the private key. So the identity is extremely important in a blockchain network. And if it's detected that, for example, like your identity is messed up, it doesn't match, like the verification process doesn't work out, then you can be booted off the network. Or other participants can vote to say, let's not, this person is not anymore part of the network, and vote you out. Yeah.
But then for enterprise, it's also, it's still susceptible to the same problems like employee doing damage because
Yes,
it's already on the
that's another great segue into why Linux One is so secure to do that. So I'll talk about that later, because a lot of it is insider attack, right? For a lot of these things. So I'm going to, okay, I thought I disabled notification. But I think I'm going to skip this. I already kind of talked about this. So I want to talk about some of the examples, just 2 examples. There's a lot more out there of how enterprise or permission blockchain is being used today. So food trust is one, and it really goes back to kind of consumer safety, consumer trust of the food supply system. So only 1 in 4 consumers trust today's food ecosystem. 1 out of 10 people get sick every year, and 420,000 die from foodborne illnesses worldwide. And 80% of CPG's businesses are partially or entirely paper-based. And 1 out of 3 fresh food is thrown out because it's considered unacceptable. And I didn't know this statistic is 1 in 5 seafood samples is mislabeled worldwide. 43% in New York City. So don't get seafood in New York. And really, it's the root cause of a lot of these issues is a lack of trust and transparency in the food supply chain. right? And so a common example is like, I think, last year we had that romaine lettuce scare. People got E. coli. I think it's surfacing again. Right. So so we actually partner with Walmart as the initial kind of client on the food trust, and now it's being used by 80 or like 90 different retailers, distributors, and suppliers in the food trust ecosystem. And really, it's IBM blockchain platform has the ledger, right? Has the distributed ledger information, and then we also offer a bunch of APIs on top for clients to access to be able to actually get insights from the ledger, to be able to put like certifications of their food on the blockchain. So, for example, like you see meat and it's like USDA certified, right? Well, is it really? Right. So actually put like a certification on a blockchain so people can actually verify that yes, it is certified. This is the date that it's been certified. Blah blah blah, all that information.
So is that without something and can the consumer access it?
So that's up to the retailer, right? So Walmart, one of the things they are looking at is creating like an app for clients, because consumers are not going to want to really care whether or not this is on a blockchain. They kind of just want to know that like this food is certified organic. If I'm paying like 5x, times like the non-organic thing, I really want to know that it's actually certified organic and be able to find some of that information. For Walmart, it's about being able to do like for food safety, right? For clients to trust to come into Walmart and shop for their food and trust that what they're getting is not contaminated. So Walmart is using the food trust to do things like verify the food supply chain, make sure that like certain foods are kept at a certain temperature throughout the whole supply chain, making sure that like suppliers and people that repackage food have their certifications up to date, things like that. And then when a recall does happen, Walmart can do what they call surgical recall, versus recalling every single piece of lettuce in every single store. You can recall the contaminated batch of lettuce from a specific farm.
So it all goes down to the consumer trusting a particular retailer, right, and forcing the retailer to take care of
Right.
their blockchain. It's not the consumer's job.
Right. So one question that people ask is like, well, how do you know like that this apple is actually organic, right? Like, because people can sort of fake that too, right? And if you're a farmer and you want to kind of game the system, you can kind of maybe, just put like a fake certificate of organic, on the blockchain. So there's one saying with the blockchain is, yes, it's immutable, so you can't mess with the history of it. So it's like if you put garbage on the blockchain, it's garbage forever, right? So you can't really move it. So IBM Research is working on and actually has debuted a product called the Verifier. So it's something that you can attach to your phone and be able to kind of scan different types of unique products, and every unique product has a different like wavelength, and then you can actually be able to verify that something is what it claims to be. No, I think it's typically used by like regulators and auditors and people that check, right? That can actually say yes, like this is actually organic, or this is actually this drug, for example. Drug is a big problem area in this space. So if you like Google or go on YouTube and search for IBM Food Trust Walmart mangoes, you'll see a video of this Walmart guy. He's like, well, when he first started this, he put a package of mangoes on the table to his top executives and be like, I want you to track which farm this came from, this package of mangoes. And it took him 7 days, or a long time. 6 days, 18 hours and 26 minutes. And then on the blockchain, it takes 2 seconds.
There was a news story a couple of
Yeah.
all, the CDC and the FDA, it's all paper-based. The guy was standing behind, because we have to go through file cabinets, like multiple file cabinets, like this, it takes us weeks to figure out some of this stuff. And then Jim said, with this, who's that?
Yeah, so actually the guy that headed up this project at Walmart is now working at FDA.
Tim was on TV.
Yeah, yeah. So
Isn't China very big on that? Don't they use already the pork for pork?
yeah, so that's another one of the pilot use cases was pork, to track pork in China. Because pork is like the favorite meat in China. So, but it can be there's a lot of contamination that happens, and so they now, like, they import a lot of pork. So that was a huge problem for China, and they tracked so they did a pilot around the tracking of pork. So I want to talk about the identity use case because I think it's very relevant, and IBM recently just launched the Learning Credentials Network. So I think that would be very relevant for this audience to hear. So when you think about identity, right, and your identity, who owns data about you today? Facebook. Who else? Your bank. Your bank, right? So basically, like anybody that you bought anything from, right? Did everybody get spammed on Black Friday by every single store that you bought anything from, right? And are they selling that information? You think? Sure, right? I mean, Facebook has a huge trust issue with their users. So there's kind of a movement to move the identity to the edge of the network, meaning give you back control over your data, right? Over everything about you. And that is built on another Hyperledger distributed ledger technology called Hyperledger Indy. So there's a company that IBM is working with called Sovereign. It's a self-sovereign identity network. So self-sovereign meaning you have control over your data. You decide who you share your data with. And maybe you get paid on it. Right? What if I share all of my browsing history, my demographic data? Give me some money. Who's benefiting from selling your data today? Who's monetizing it? Not you. Right? And so there's a huge movement around this. It's a decentralized approach that establishes trust and puts the end user in control. And so it really is based on decentralized identifiers. So that means you own and you govern your identity, and then other entities will add to your identity, right? And I will talk about what that is later. It's about verifiable credentials. Again, it's cryptographically backed statements of truth. And again, verifiable credentials means, like, let's say you get a degree, right? A college degree. And Bergen College says, yes, like, I'm attaching my identity to this. I say, yes, you definitely do have this degree, your computer science degree from Bergen College. And then you can take that credential and you can share it with a potential employer. Be like, hey, look, I actually do have this, and here's all the relevant information, and my GPA, for example, whatever micro credentials I earned along the way, and that's it, right? And then once you get the job, you can, like, revoke that access, right? Or if you don't get the job, you can revoke that access. And it's a decentralized key management. So again, key is very important in this case now, because if your private key gets stolen, it's not just like the asset, it's you. It's your whole identity and everything associated about you. So that's very crucial. And the IBM mainframe platform has the highest rated, what they call hardware security module. So it's really protection of private keys at the hardware level. And the master keys never leave the module. And if the module is detected that it's tampered with, it erases all the master keys. So decentralized identity. So here's kind of a flow of how that works, right? So the issuer will issue you some kind of a credential, right? and you are the owner or holder of your identity. And then you can present your credential to somebody else. So for example, like, just, I know it's not being used this way today, but for example, like, if you have your identity and you got your driver's license, so the DMV will issue you a credential, a license credential. And then you go to a bar or something, you can present that credential. But today, if you go to a bar, you have to show them your whole ID, right? And it's got your address on there. It's got a lot of information on there that they don't really need to know. They just need to know green light or red light, yes or no. Like, are you over 21 or you're not? That's it. They don't even need to know how old you are. But today, though, I was like, it's like judging, right? So, anyway, so there's that aspect of it. So there's something called a zero knowledge proof, which is basically you're just sharing enough information to get the job done, right? And not anymore. Again, it's for protection of privacy. So here's an example. University will issue credentials to say you are now a doctor. Like, you've gone through the rigorous pre-med program and you've done your whatever internship or residency, you're now a doctor. And you can then take that credential and show it to the hospital that you're applying for a job to, and then they can look at the credentials that basically are attached and the identity attached by the university, because the university is basically signing it with their public certificate, right? Saying, yes, now you are a doctor. And then the hospital will say, yes, you're a doctor. And this process reduces resume fraud and potentially like transcript fraud. Like, a lot of employers will say, give me your resume, give me your transcript. So there's some fraud happening in that space, and employers are not actually hiring the people they think they're hiring. And now that you work at a hospital, the hospital now can also add a credential to your identity to say, you have a job now. Congratulations. You have a pretty good paying job. And now you can take that to the bank and say, I need a loan for a car, I need a loan for a mortgage. And the bank says, okay, I can see that the hospital has attached their public certificate to the you have a job transaction, and now I can verify that you have a job. And now you can get a job. And then now that you have a job and you have a credentials, and you can present multiple credentials, to, what is this? So complex credentials, you can present multiple credentials to get additional services, either from the government or from the bank. So now I want to talk a little bit about security. So why is key protection so important in blockchain? And Dilbert always has a comment, has a comic about everything, right? So here, like Dilbert's like, I put $5,000 into the crypto wallet you created for me, and it disappeared. You're the only other person who knew my password private key. And he's like, well, that's not true. I shared them with Dilbert to create reasonable doubt. So it's very important, right, to keep that key safe. So there are different kinds of hardware security modules on the market today, and and it's all like the certified FIPS 140-2, level 2, level 3, level 4. If you Google it, they have nice tables to talk about what each level of certification will get you, right? So basically, level 2 is terrible. It's as good as like software security modules, right? Level 3 is better. It has tamper detection and response for covers and doors. So Amazon, Google, they have cloud HSMs, and it's usually backed by something called Gemalto, and it's a level 3 certified HSM not to hold your key, because the HSMs typically just have a master key, and the master key is used to wrap your key, or to wrap another key that's used to wrap your key. There's like layers of encryption happening, right? So even if the hacker gets a hold of your key, it's not your real key. It's actually protected by another key that resides in the hardware. And for them to get to the master key, they have to like physically get there, because the master key never leaves the hardware security module in the level 4 case. and they have to like do different attacks. They can, you know, pour some acid on it, or, you know, like really try to tamper with it. And our HSM is designed by some extremely paranoid people in Zurich, who's doing like all of these different attacks to it, to make sure that it is not just tamper detect, but it's tamper proof, so that within nanoseconds of detecting an attack, all the master keys are erased. And because of this, IBM is also now like talking to different digital asset custodians about our technology, and they have a very high interest in using our HSM for that level of protection. Because if your private key is stolen, all of your crypto or digital assets can be stolen as well. And you mentioned about the insider attack, right? So what about the people that are managing your wallet? Because up to a certain amount of crypto digital asset ownership, the federal regulation says you have to have somebody else custody your wallet. You can't do that yourself. And so how can you trust the people that are providing that custody service to you? So we have something called a secure service container, which is basically this kind of a secure enclave where you're running your hot wallet or your blockchain solution or your identity solution, and it prevents the administrators from being able to access that information at all. Everything's encrypted. If you do a memory dump, that's encrypted. There's no SSH access into the environment. It's all done through approved or whitelisted APIs. Okay, because a lot of the hacks that have been done through the back door. So again, these are some of the security benefits that the Z platform brings to the table. And so now, you know, we're talking to clients not just about permission blockchain, but also identity use cases are very key in that. There's crypto asset custodians are very hot on making sure that private key is secure. All right, so I don't have a lot of time left. I want to do a quick demo for you. It's called the Vehicle Manufacturer Network. And this is kind of a picture representation of what that network looks like and who the participants are. So how many of you have gone through the process of leasing a car, or know your parents that have leased a car or bought a car? Okay, good. And how was that experience? It's painful, right? You got to go to the DMV with all this junk, and then of course you don't get it right the first time, and you wait in line for an hour, and like, go back home. You're missing this document and that document, and you're like, no, it's horrendous. So this is a network that has the manufacturer is part of the network that manufactures the car. It has the DMV as part of the network, and in this case, the DMV is called the VDA. So the VDA, because this demo was developed by developers in the UK, and VDA is their version of the DMV. Yeah, so there's a version of hell on earth in every country. So, no. And then there's insurance, right? You also have to get insurance in order to actually take your car home and be able to drive it without getting ticketed. And so this demo really showcases Paul, the buyer, the manufacturer, the VDA, the insurer. And other people that can join the network are maybe the police, right? And you don't have to give them access to everything. You just have to maybe give them access of all the current registration list of all the current vehicles. Because I got pulled over in Dallas one time. I rented a car. It was a brand new car from Hertz, and I got pulled over because I forgot to turn the nightlight on. I was driving at night, and it's not the first time that it's happened, and it's terrible for proliferating the Asian women bad driver stereotype. But I got pulled over in Dallas, and the cop came over, and he's like, your lights aren't on. Like, let me see all of your paperwork. So I gave him all the paperwork, and went back and forth in 15 minutes. I sat there, like, being very nervous. I'm like, what's going on? Like, do I have a criminal record in Dallas that I don't know about? So finally it came up, he's like, your car is not in our database. I don't know, where'd you get the car from? I'm like, it's from Hertz. Like, I have all the paperwork here. And he's like, oh, I think it's because it's such a new car that our registration database for car registration hasn't been reconciled with the DMV's registration database. Yeah, so he's like, he let me go. He's like, I'm from out of town. I'm so sorry. But it took a long time, right? He could have really just gotten that done with and moved on with his life, and also let me go, and ease my anxiety a little bit. Anyway, so I want to show this demo real quick. Yeah, I don't know why it's not popping up here.
Just walk us through what would happen.
Okay, so essentially what should happen is the insurer will get a notification that says Paul wants to get insurance. Do you approve or not? And I'll say approve, and then you can through the Node-RED interface connect an IoT device that attaches to your car and be able to push certain events, so you can simulate overheating events, simulate oil freezing, simulate a crash, and all of that is also tracked on the blockchain. So you'll be able to see it on the insurance page for the insurer to be able to say, well, is this person, should I increase this person's rate for next time or not? A lot of insurance companies are doing this today already. I think Progressive has something that you can attach to your car for better driver discount. MetLife is looking at doing something like that. And you can also attach AI to it. And then another aspect of that IoT data that can be useful for the manufacturer is the manufacturer can look at post-manufacturer failures. So they can get ahead of recalls and serious safety incidents to their consumers ahead of some serious accident. So if they're seeing kind of a pattern in overheating, in engine overheating in a particular model, they can say, well, let me issue a recall right now versus wait a few months later after something catastrophic happens. All right, thank you. Sorry for this defective demo. Okay.